Okay, so for today's demo, we have set a one topic, say as a logistic regression. Okay, so we will understand about this logical regression tech algorithm, and then we will jump to the demo part. If we will see how we can do it practically by looking at a very real-time use case. Okay. So this logistic regression, though it is a name as a regression, but it's a classification problem statement. And this is the very basic, or you can say the first algorithm by which we can deal with the classification problem statement. Okay. So this logistic regression is part of the supervised learning, okay, where we're going to have multiple independent variables which are corresponding to be predicted for the dependent variables. Okay. So this basically this logistic regression is working on the sigmoid function, okay, where we are predicting based on the probability on the event occurring that we are having. So that the probability can be into the binary format also, let's say 1 0 or any flag format, yes or no. So that also we have. So there are only two output majorly in binary classification. So that could be yes or no, or yes stand for 1 or no stand for 0. That also we can predict. Okay, and to segregate, to divide these two classification, we are using one threshold value. Okay, there is a, when you plot a graph, that is a S-shaped curve graph for the sigmoid function in logistic regression. So for that we are using a threshold value stated as a 0.5 sometime. Okay, so this is a very high level of the logistic regression. So now we will jump to the demo part of it. So for today's session, we have taken regression use case statement of the diabetic analysis. So let's consider a scenario where we have a data from some hospital, and from that hospital, based on the certain independent variable, we have to predict whether a person can be a diabetic or no. So for this, let's first have a look on the data. Okay, so this is the data which we have in our Excel sheet, which have various columns like pregnancy, glucose. Okay, so to begin with the problem statement, let's first understand about the data. So we're going to have this data. We will do some sort of analysis on this, some sort of EDA, pre-processing and the transformation we will do on this data. And then we will use this data as a testing and the training purpose for the prediction of my output. So if you see this data, so this data having multiple columns. Okay, so pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree, function, age, and the outcome. So this outcome is my output label. Okay, where I am representing 1, the person could have a diabetes, or 0 represent person do not have a diabetes. Okay, so based upon these independent variable, which is column A to H, we are predicting column I. So what could be the possibility? So you can see these all are the numeric variable. There is no categorical variable. Okay, so we can simply feed this data to our machine learning model. Okay, so now let's read this data. Okay, and then start our demo practicals. Okay, so this is our Jupyter notebook. Hope this is a very basic. So here we will be using. So let's create a one notebook here by using the kernel as a Python 3. Okay, so for this, first of all, we have to import some library because we are going to use the Python. So we will import the Python library. So there are a set of libraries that I have copied here. So we simply can take all the library. Okay, let's create multiple shell. So by pressing Shift and Enter, we are able to run this library. And if you see, there is a star mark. So when we are done, these all libraries are imported in my Jupyter notebook so that we can start reading our data. Okay, so now to do the coding of it, first we have to read the data. So for that, let's say I'm declaring a variable named as a data is equal to PD, stand for pandas. Okay, so that I have not declared, I think. So that also we need to declare. So we will say import pandas as PD. Okay, so that also we can import. Yeah, import it. Then data equal to PD, which is alias for pandas dot. We want to read the CSV file. So read CSV. Okay, and we will use our file name. So what is my file name here? So let me copy this file name and I will use in my code. So diabetes dot CSV. Okay, so I again press shift enter. So this shell has been run successfully. So let's have a look on the data frame which I have created. Okay, so we can check the type of the variable which I have created, whether it is a data frame or series or what it is. So I could say this is a data frame. Okay, so now let's have a look of this data frame which we have created by using the head command, which give you some initial record of this complete data frame. So I hit enter, shift enter, and I could see that those 5 record I could see that we are in a good shape of data. All the data has been imported. Okay, so once you load your data, after that you have to first analyze your data. Okay, there could be multiple ways to analyze your data, but as part of the demo we will use only one technique, say as a null value. So here first I need to check whether my data contains any null value or not. So based upon the result, we will take the next step. If it is having null values, then we can remove the null values, or we can do some apply some imputers technique by using the mean or the mode or the median. Okay, so based upon that, the result we will see. So how we will check the null value? So we will call our data frame dot, there is a method called isNull that we will use. Okay, and then dot sum. So whatever the column output I'm getting, I'm going to sum it. I hit enter. Now I could see the result against each column is generated. So that is 0, 0, 0. So we could see we do not have any null value in our record. Okay. The next EDA we also can do, we can check our categorical classification type here, that what is the type of my classification. So for that, what we can do, okay, we will check our output column as an outcome. Okay, I will copy this and I just want to check. I do control V. Okay, outcome. Okay, here there is a function called value counts. So this will give me the type of classification given to me. Okay, so I could see there are 1 and 0 binary problem. So 0, there are 500 zeros record are present, and for 1 there are 268 records are present. Okay, so if you want just for the data visualization, we can also simply plot a graph for this data, and we can see in real graphical presentation. So for that, nothing, we simply have to take this and we have to apply simply a plot, and let's plot a bar graph here. Okay, dot bar bracket. So if you plot this, so there is a bar graph is created. So if you could see that for the 0, we have a 500 zeros number of record, and for 1 we have a approximately 268 till here. So this is a graphical visualization of my data which we are doing. Okay, now for there could be multiple analysis technique, but as a demo we will use these two only. Now let's divide this data into dependent and independent features. Okay, so as we know, X that I'm creating as a dependent variable, all independent variable. So calling my data frame dot ilog function I'm using. Okay, and then I want all the column except my output column. So pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, and this, and till age. I want all these columns as part of my independent variable. So I say ilog, and I will use a split operation over there. I will use so that is like column, comma, and I want -1. So I think this will give us, yes. Okay, so if I run, If I want to see the content of it, yes, I could see all the independent column here. Okay, similarly, let's create a dependent variable. So y is equal to data dot, and it could be ilog. Okay, so the same I'm going to use. So simply copying, pasting here from here. Okay, and if I remove this, so here my y has been created. So if I see the content of y, I could see this is my outcome column. Okay, which is my output label here, outcome 100. So I have divided x and y, independent dependent variable. Okay, I looked into it. Now there are one more technique is called as a feature selection. Okay, so there are many techniques are present like correlation, extra tree, or logistic. By that also we can do pie charm. So they are the various technique to do the feature selection. So we can get to know that which is the best suitable feature across all this. Okay, so that will take longer time, so we can skip as part of this demo because we have a time constraint, because that will take a little time. Now, so moving further, now we have divided x and y. So now let's create a train and test. Okay, so that we can train our model and then simply test our model. So to create a train and test split, we will use, let's say, x train, comma, okay, and then x test. Now for the dependent variable y train, comma, and then y test. Okay, so these are the variable I am declaring for my x and y train and test. Okay, I will call a method called as a train underscore test underscore split. Train underscore, yeah. Okay, so I will call my x comma y independent variable. On this I want to apply. What is the test array I want to give? Okay, let's say test underscore sig is equal to 0.2. So here I'm saying that my 0.2 is my test. Okay, and 80% is my train data will be split it, and 20% I'm going to use as a test data. Okay, so there is one more random state also we can use. Random state is equal to 0. Okay, so that function also we can use, how we are going to randomize the data. So if I run this, so this has been run successfully. Now I have my 4 variable train and test in the form of x test and y train and test and all. Okay, so if we want, let's have a look one of the data. So if I see x train, I ran it, so I could see, okay, we have 614 rows. If I want to check the length of it, so len, there's a function len and x train, I could see 614 rows are there. Okay, it's a 80% of total data. If I want to check for the test, I will use the test variable here, and I could see this is the 154 rows. Okay, 20% of my total data. So that's how we have splitted our input data. Now, as part of the best practice, oh, sorry, I deleted. Okay, now we have to standardize this data. We have to take, because this variable can, the data can be at multiple scale. So we have to take this data on a one scalar. So for that, we can use the standard scalar or min-max scalar. So let's say for this time, I'm using min-max scalar. So I think I have already imported the library for that. Yes, this one. I simply copied the name here. So I'm creating an object SC stating min-max scalar. Yes, so this has been created. Okay, now let's create a standard data. Okay, so I'm marking as a SC standard scalar. Train data I'm creating. So SC dot, I will call a transformation method fit underscore transform. Okay, and which data I want to transform? That is a X train. Okay, similarly, the test data also, I marked it equal to SC. Okay, and the same we need to copy paste here the X independent all variable we need to standardize by using the standard scalar. I run this. Yes, it ran. So now if you want to see the data of it, let's say the scaled data which we are getting. So how does it look? So it will be vary between 0 to 1. Okay, so you can see whatever the data, if you see the X data, so X data look like this, like in pregnancy you have 6 1 8 1 0 10 12 10 2, but when you standardize your data, so your data is lie between 0 to 1. Okay, so that's how we will look the data. Okay, now my data is on same level. Okay, now let's do one thing. Now my data is ready. Okay, now I will create a model. Okay, I will create an object by using the logistic regression. So I will name as a, let's say, log reg is equal to that object I'm creating and logistic regression I'm using. Yes, so my object has been created. If you want to see the log, this object, what this log object is, so you could see this is a logistic regression where we have a various hyperparameter tuning. Okay, we could see C values, class weight, dual, and the fit intercept. So there are multiple hyperparameters, so that we can see. Okay, so I have created the logreg object. So now this object I have created, now this object I have to fit, okay, on my data, on my test data, so that I have to fit. So what I will do, I will simply call a fit method here, okay, dot fit, and I will use my scaled data. So that is like X train standard scalar data SC, comma, the Y data, the Y train, which we have created. So based upon this X underscore train data, I'm telling my model, this is the output. So whatever the data we are getting, rows record we are getting in X, accordingly, we are generating the Y train, whatever the we are having binaries value. So this we are training to our model. Okay, so if I run this, yes, so this has been run. Okay, now we have fit our object. Now my object is ready. Okay, my object is ready. So now we can pass our test value to this object. Okay, for the prediction. Okay, now my object is ready. It's trained. Now use this object, logreg object, for the predictions. So let's create a, let's say y pred, one variable I am creating is equal to logreg that I'm using. There is a method called predict. So that I'm using. Now on which data you want to predict? On test data. So that is our standard scaled data. X test SC. Okay, so that I have used. Now this I ran this. Yes, it ran. Now I just want to see the what is of my prediction value. Yes, so these are my prediction values. Okay, so this is my output I got. So 1 0 1 0. So the binary value I got in zeros and 1. So that is my predicted value output. Okay, now if you want to check that for which corresponding independent variable it is, so we have to map it with the help of indexing. Okay, so we can identify, okay, for this one particular record, what could be the input. So we can do this with the help of mapping indexing. Okay, now we got our prediction. So what is the next next step is like, we have to evaluate our model, that whether our model is working properly or not. So for that evaluation, we will use a matrix called as a accuracy. Okay, so we can check what is the accuracy I'm getting, how much my model is predicting the true value or the false value. So for to get the accuracy, so there is a library we use, matrix. Okay, so this library we use generally. So what I will do, let's create a one more variable. Okay, so that is nothing but I could say, let's say log underscore accuracy, ACC. I'm just writing as an abbreviation. Okay, I will copy this, and one method under matrix library is accuracy score. Okay, so that I just hit the tab and I got my accuracy score. Okay, now whatever the data I have, test data and the predicted data. So I'm going to compare these two data so that I can compare and see what is the accuracy score. So I'm using Y test, 20% of my Y test and the predicted value, my actual value versus predicted value, that I am comparing with the help of accuracy score, and I ran it. Now let's see. So this also ran successfully. Cool. So now just check what is this is my accuracy. So I hit enter. I could see I'm getting accuracy 0.75, 75%. Okay, but that is not exactly a really good accuracy. Ideally, we should get the accuracy like nearby 90%, 90 or above 90. So that seems to be a good accuracy. Okay, so we again can do a lot of EDA. We can do again a lot of pre-processing. Okay, so transformation we can apply to increase my accuracy. The next step we also can apply to increase my accuracy. We can also use, there are various hyperparameter tuning. Okay, hyperparameter tuning, that also we can use to increase my accuracy, to train my model with for the better results. Okay, so there are two methods we can use. One is the grid method. Okay, another is a random search. Okay, so this hyperparameter tuning also apply. Okay, there are multiple values, multiple components are there under hyperparameter tuning. So we can apply those and we can increase our accuracy so that my model can predict in better state of form. Okay, so that's how we have developed our logistics. So that is it. Okay, we done all the jobs. Okay, now we are getting our predicted value with a 0.75 accuracy. Even though this is not a good accuracy, for that we have to do a lot of EDA pre-processing and the transformation, and we can increase our accuracy. And we also can leverage the hyperparameter tuning also to increase our accuracy. So that is it for this logistic demo part. Okay, so if you guys have any question or doubt, so we can have a QA session now. Thank you.
No, there is no doubt.
Okay, cool then.